Cosmic Pie Podcast, episode number 28. I'm your host, Wayne Barkhouse, and with me today is
Robert Moore, and also with us is
Dean Smith.
Dean Smith, who you've seen before again, but we're trying a new setup wherein we're actually zooming him in to our little conference instead of crowding up our little room here in the studio. Hopefully he's able to be heard and everything, so yeah.
So when I look at you, Robert, I'm now looking the other way.
Oh, right.
Oh, you got him mixed up again.
I could fix that. I'll wait.
You want to fix it in real time? Show people what we can do with this fancy OBS. Look at Robert move. Now look at me move. You see how this works? There we go. Oh.
Now we can look at each other.
The stars are aligned again. You see that? That's why we have these headphones on today. It's not our usual outfit, if you like. We're testing the Zoom connection with Dean, who's in his office upstairs. And if this works out, Robert, this allows us to bring in multiple guests.
And that's the whole plan. That's the idea, is to try to bring in some people who maybe not be here at UND.
Right, so this is a good testing ground, if you like, to see if we can work out all the audio issues and so on. Now, this is episode number 28, and like every other episode, we do ask that if you have a question or a comment related to anything to deal with science, physics, astronomy, astrophysics, whatever, please put them in the chat. We do have that running at the moment. And also as a disclaimer, which is kind of getting boring after this 28th time I'm mentioning it, but Robert, how would you like to do it today?
Okay, I guess I can. The opinions that we're going to express are undoubtedly those of myself, Dean, or Wayne. They are not the opinions of the state of North Dakota, the University of North Dakota, the department, any of that stuff. So if it's factual, it's the science, that's good. But if it's just us talking, yeah.
And remember the rule of thumb. If anything is said that's really bad or controversial, it was probably Robert that said it.
Blame me.
Isn't that how it works?
That's how it works.
Okay. That's what I was told.
But blame the tech guy,
Anyways, today we're going to start off with talking about what's been in the news lately, and that is the landing on the moon for the first time. It's a soft landing. You can land on the moon, which is the easy way of doing it. That's a hard landing.
Right. I mean, you can do that here on Earth.
Well, that's it. Now the technical thing to do here, of course, is the soft land on the moon.
Right.
And so India has done that. They have joined 3 other countries that in the past have also soft landed on the moon. That includes both Russia, which is the Soviet Union at the time, the United States, and China.
Right.
So that makes India as the 4th country now that land on the moon. And we're all happy for that, aren't we?
Absolutely. I mean, the more the merrier, I say. I mean, the more eyes on a problem, the closer you are to dealing and understanding that problem.
Do you realize that every time I look up at the moon in the sky, a little bit inside of me cries?
Oh?
And it cries because I always imagine what would have happened if we would have kept going and exploring the moon since the late 60s.
Yes.
You can imagine what would be there today. I mean, could I look through a telescope and see lights from a base that's on the surface of the moon that's facing the Earth? I mean, you just don't know. It would be like Antarctica, the world will be, what's it called in Antarctica? Do you remember? Morrow Beach or something like that? Yeah, imagine the equivalent on the moon.
Yep.
Right, so teams of scientists were going up there every month or so, or every couple of months, and then swapping up with other people that had been there. So you trade, different expeditions and learning and working on the moon and exploring it and so on. And yet, it's almost like everything froze since the early 1970s.
Well, let's face it. The political impetus behind it died. The enthusiasm for it died because it started becoming routine and just people started going, why are we spending all this money for something we've done over and over and over again?
And that will happen too when we go to Mars.
Yes, it will.
It will be a big fanfare the first time human beings land on Mars. And then all of a sudden when we do it the second, the third, the 4th time, we're like, why are we spending this money sending people to Mars? We've already done that.
Right.
Then we'll have to think of something new to do.
Yeah.
But that's human nature.
It is. And it's a shame. You've got to keep going for the next big thing. And it's like sometimes we need to sit where we are for a little bit and not make it where it's routine, make it better than routine.
Now, well, NASA tried that, and actually, remember, I don't know if you remember this, one of the selling points of the space shuttle was to go up there so often, and at first they thought they could bring the shuttle down, refit it to go again, and launch it 14 days later. So
Right.
every 2 weeks, the same shuttle would be launched into space. It would make space travel so routine, it would be like taking a trip to Pittsburgh. Nobody would care.
Right.
And in some ways, that's what happened. It didn't quite get the reusability. It took many, many months to process one shuttle to put it up again, and it cost a lot more money than what they initially planned. But they made space so routine that the average person who's not interested in the space program got bored of the whole thing.
Right. Ignored it until something went wrong.
Until something went wrong and caught people's attention. Not unlike Apollo 13. People were starting to ignore the moon program, the Apollo program, when they had the accident, of course, the exploding, I think it was an oxygen tank.
Oxygen tank.
On the command service module, and that got everybody's attention, life or death situation at that point. And that's unfortunate that
Right.
that happens. But that's the nature of the beast that you're working against.
Yep.
Now, just the other week, Russia tried the soft land on the moon.
And
So this was the first time since it became Russia. It wasn't the Soviet Union, but it was on the order of 46 years since they last landed on the moon in the 1970s, and we saw the consequence of that. They
Yep.
landed all right. But
landing is going to happen.
yeah, but it wasn't a survivable landing in
Yeah.
terms of their
What
instruments.
was it SpaceX called it? Rapid, unexpected, rapid,
Make it work. Deceleration?
yeah, something like that.
I forgot.
That was one of their
Disassembly, that was the word,
Disassembly,
yeah.
that was the word, yeah. So it's nice to see other countries getting involved in exploring the moon. In fact, that may, give more motivation to us, the United States, to return to the moon.
Or maybe cooperate with some of these other governments, start cooperating with the Japanese Space Agency and doing more with ESA, the European Space Agency, for those who don't know that accurately.
Well, I mean, we have a good legacy now in the International Space Station, hence the
Right.
name International. And the Artemis program does involve, people signing up to do various things. So we're trying to get a lot of countries
Right.
that otherwise would not be involved, like countries that weren't involved in or aren't involved in the International Space Station, to become involved
Mm-hmm.
in exploring the moon. And so that's starting to happen a lot more than it has in the past. So that's good to see. That
It's
spreads
good to
the
see.
risk, spreads the cost.
Right.
Even
And-
if someone dominates the bills, still you're getting others involved, and who knows what expertise and what you can bring into the program.
And if you haven't noticed, that's something that we're very, very big about, is getting everybody involved in science. I mean, this affects all of us.
Exactly. So, but unfortunately, when things happen in science, a lot of people get their news through mass communication, the
Yep.
media, essentially. And sometimes, unfortunately, the media just gets it wrong. As an example, Robert, if you want to look at our first slide today. So the headline, this was published, you see, on August the 23rd, so almost a week ago. And it says, India becomes fourth country to land on the moon.
If they just stop there.
If they stopped there, it would have been beautiful. First on the South Pole. That's the problem. India did not land on the South Pole of the moon. I'm sorry. They landed at minus 69 latitude, south latitude,
Right.
right?
And what's the South Pole? What's its latitude?
Yeah, minus 90.
Minus 90.
So that's like 21 degrees away.
Right.
Okay? It's equivalent if you were trying to land or be the first person on the North Pole of the Earth, and you got to the northern part of Finland or Sweden or Norway to say, hey, I made it, the first one to make it to the North Pole. People would laugh at you, say, you're not on the North Pole. You
Right.
have to go further north. Well, this spacecraft did not land on the South Pole of the moon. That is still out there. No one has done that yet.
Right.
Now, why was it done like this? Well, it was PR value, and
Mhm.
certainly India, not to make any accusations here, I'm sure they didn't go out and discourage the people from using those headlines, because that got them headlines.
Got them headlines.
Right? But they did not land on the South Pole, so no one has landed on the South Pole of the moon yet. That will happen, and that's an interesting spot. You want to tell viewers
Yep.
why that's interesting?
Well, there's pretty much, we know now that there's water ice trapped inside some of the craters on the south polar moon. So water is one of the things that you have trouble. You've got to carry around with you if you want to keep things alive. And okay, apparently Wayne, we can't hear you at all. I don't know why that's happening. Everything's showing green on the board. Interesting. Anyway, I'll keep trying to go. We'll see if it corrects itself, Wondergoon. Thank you. There's ice. There's water there because you can melt it.
Now, Dean, do you want to add in anything here so people can see
So we can see if can you hear Dean? Let's let Dean talk for a minute.
Yeah, I'm just listening, and I'll admit I haven't followed the lunar spacecraft too much, but yeah, that is the big thing is looking for ice, because then we can use that for water and oxygen later on.
Right.
So
and so now let's try Wayne. Wayne, you talk for a minute and let's see.
Okay, let's just do a test here. If people
I
can
hear
me, can you just put a message in the chat then that you can hear me speaking now? Please and thank you.
And in case they couldn't hear you, if you could hear Wayne speaking, put a message in the chat. If you couldn't, well, we need to know that too. So yeah, we're trying to work out some difficulties apparently.
I'm speaking now. Then, if people who are tuned into this broadcast, if you can hear me speaking, could you please put a message in chat that you can hear me? This is Wayne speaking right now.
All right.
Not seeing anything.
Not seeing anything in the chat.
Let's just continue on.
Okay.
So let's go to the next slide, Robert.
Okay. And so the next slide is...
So the next slide is actually an image taken of the lunar surface, taken from the lander. You can actually see the legs of the lander in the lower right. It's kind of interesting. It's in that south polar region. I guess you could call it that, but it's not at the South Pole. And so that proves that this lander has successfully soft landed on the moon's surface. So that's interesting.
Yep, that's always interesting.
Now, the other thing that the lander has on board it is a rover.
Is a rover.
To the next slide.
Okay.
And you can see the rover now on its way out of the lander, so down on its slide, basically, or chute, its ramp, if you like, proceeding to the surface of the moon. And there are, even images taken of the moon that were taken more recently than the one that you're seeing here actually show tracks. So it's actually tracking on the surface of the moon.
Oh, right. I've seen those. Yeah.
Yeah. So they're actually moving around now on the surface, exploring the part of the moon that they landed on. So it'll be interesting to see what happens in the future to the spacecraft. But to note here that from an engineering point of view, the rover was designed to last for approximately 2 weeks. And the reason for that is because it runs on battery and there's no other way of generating electricity to keep the rover warm at night.
Oh, right.
So once the daylight is gone, and that lasts 2 weeks altogether, all right, and so once the daylight is gone, then you're in perpetual night for 2 weeks. And during that nighttime, the rover is supposed to get extremely cold. In fact, they don't think that it will survive. But who knows?
Who knows?
We'll see.
Yep.
We'll see what happens.
So, yeah. I was just noticing that there's limited solar panels or anything on it. So,
yeah. So, I mean, what you want to do, of course, once this is approving, it's like a laboratory that India is using to prove their technology. So you can be assured that the next generation of vehicles that arrive on the moon will be able to survive much longer. And it wouldn't surprise me if they have vehicles that are looking at years-long type of duration.
Right.
You go through the expense and stuff, you want to be able to ensure that your vehicle lasts long. I mean, it wouldn't be good if the United States sent an orbiter to Uranus and spent all that time and money to get there, and so, by the way, it only is going to last 2 weeks. That's not a good investment of our money. But
no.
If you're the first time somewhere, first time doing this, really, of course, you've got to go through all those baby steps to get everything to function as you'd expect in a mature space program.
Right.
Put it that way.
And that's kind of the thing is they're just getting started. So it'll be interesting to see what happens and where they go from here.
Right. Now, speaking about the moon, Robert, I think you have something you want to talk about the moon, not related to the landing there by India. that.
I'll come back to all three of us for a little bit for all of this. I do have a slide, so we'll get to that in a minute. But yeah, I've been seeing all over the place a usual thing that makes some of us just cringe. And that is that there's going to be a final full moon, a second full moon, here at the end of, what month is it? Oh yeah, August. And so people are going, oh, it's a blue moon. Well, that's what that means. It doesn't mean that the moon is going to be blue in color.
Oh, darn.
It means it's the second full moon in a month or in a season, the fourth full moon in a season. So that's what's going on with that. And the term blue moon comes from the 16th century, as it turns out, in that people started using that phrase to explain or say something that doesn't happen. It's a unicorn. And so it happens at a blue moon, it became the expression. But then we started referring to the second full moon in a month or the fourth full moon in a season as a blue moon as well.
So, I mean, like, I only win the lottery once in a blue moon?
Yeah.
Does that mean I should run out and get a Powerball ticket then for the end of this month?
No, it probably means the 16th century expression, which is something that doesn't happen.
Okay. Well,
Darn
it
it.
certainly hasn't happened that I won the Powerball, by the way.
Right.
Because if if I win the Powerball, you will know,
Right.
and I won't even tell you. You know how you will know?
You won't be in that chair.
I won't be in here anymore. You'll never see me again.
Well, I hope that's not true, but
I might Zoom you once in a while.
Okay. But the interesting thing is this full moon will also be what's called a supermoon. And all that's referring to is where the moon is in its orbit. A full moon that happens when the moon is at perigee, its closest approach to Earth, because the moon is again in an elliptical orbit. So it has a point where it's closest to Earth and a point where it's farther away.
Now, do you want to explain where the moon is when it's full relative to the Earth and the sun?
The full moon always occurs when the Earth is between the moon and the sun. So in other words, the moon is on the opposite side of the Earth from the sun.
So,
Okay.
so the sun, Earth, and moon would form a straight line.
Would form a straight line. The best way to explain that also is that at a full moon, the moon is going to rise as the sun sets, and it's going to set as the sun rises. They're on opposite sides of the Earth.
Now, of course, this begs the question, if the Earth is between the sun and the moon, when the moon is full, why doesn't the Earth block the sunlight from reaching the moon so we never would see a full moon at that location?
And that has to do with the fact that the moon, Earth, and sun aren't on the same plane. The moon's orbits actually tilt a little bit. So sometimes it's above the Earth's shadow, sometimes it's a little below the Earth's shadow, and then occasionally it does hit in the shadow.
And what do we call there when it hits?
Well, that's an eclipse.
And what type of eclipse?
A lunar.
A lunar eclipse.
Yeah.
Now, do you remember that angle, by the way?
I do not remember that angle.
About 5 degrees.
5 degrees?
Yes.
Okay. So Dean supplied the angle for me. About 5 degrees, apparently, then.
Yeah, it's 5
So-
degrees, which means the moon could be 5 degrees above or below the plane of the Earth.
Earth going around the sun,
Orbital
yeah.
plane. So that's 10 degrees in space. Do you remember what is the size, the apparent size of the moon?
I want to say
Half
it's
a
about
degree?
half a degree. Yeah.
Half a degree. So how many moons could you fit in that 10-degree swath or slice?
20?
Yes, 20. So that's a huge amount of space that the moon could be above or below. You see, that's why only occasionally
Does
then
it
will
hit.
the moon be in that right position with the Earth and Sun that you'd have the lunar eclipse.
Yep. But getting back to the supermoon, what does that mean as far as what the moon looks like? And that's where my slide comes in. And when the moon occurs at perigee, a supermoon, it looks roughly 14% bigger than a apogee full moon or a micromoon, and results in about 30% brighter because, again, the surface area is what determines the brightness in this case. And with a 14% bigger moon, you get about 30% brighter moon. And so this is why people make a huge deal out of this. Oh, it's a supermoon. Except it's not really that big of a deal. It's 14% bigger. you're not really going to notice that by eye. This picture, in fact, is still greatly exaggerated.
So when the moon's at its closest point in its orbit to the Earth, and it happens to occur during the full moon phase, it's not as if the moon's going to fill up half the sky when you look up.
Right. It's still roughly going to be half a degree in size.
Because if you actually look at some drawings that some people have made, and here we go, another shot at the news media, they almost give you that impression that it would fill up half the sky
Right.
when the moon's at this quote-unquote supermoon position.
And it's like, no. It's. I will always encourage people to go outside and look up in the sky. But don't get all bent out of shape that, I missed the supermoon.
But you know what goes along with that?
Okay.
You know what goes along with that?
What's that?
Dean, how many times have you heard people say that when the moon is near the horizon, it's way bigger than when it's more, like the furthest it can be above the horizon?
Oh yeah. Yeah, it does appear bigger, but it's not actually bigger.
Right.
Right.
So in science, then, how would you show that the moon does not change in size when it's near the horizon to when it's its fullest extent above the horizon? You would go out and measure,
Mm-hmm.
right? We do the experiment. We don't just look and then
And
use
say,
the human senses.
yeah.
You want to go and actually do the measurement, correct?
Hold up a yardstick against it.
Yeah. Hold up some device. Use your thumb and see if it just covers the moon, when it's the highest point in the sky. And then try it when the moon is near the horizon and see if there's a significant difference in the size of the moon, parent size, relative to your thumb. And you'll see that there's no perceivable difference.
Right.
It's an optical illusion. Our senses can be fooled.
Yep.
Good example, walking in the desert. You look up ahead, look at that lake in the distance. I'm dying of thirst. I can't wait to get there. I'm so parched, right? It's an optical illusion. Our senses can be fooled.
And that's why you don't trust them. You put a yardstick against it.
Yeah, you do the observation.
You do the observation.
Experiment.
There you go. And so we'll encourage that as well. So I also wanted to mention one more thing, and that you'll hear a lot of terms referring to various moons. And so you've probably heard of the harvest moon. Well, the harvest moon is just the closest full moon to the autumnal equinox.
Right, so the time when in the northern hemisphere we're bringing in the crops.
Right. So that full moon in October, sometimes as late as a little into November, that first full moon that's right there next to September 21st to 23rd, the autumnal equinox, that's the harvest moon.
Going into November makes sense. You know why? Especially around here.
Why is that?
It's because I have an apple tree in my backyard, and it's Macintosh apples.
And
Now,
they like a little cold.
If I pick those apples on, let's say, the 1st of August, they're small, and they're very bitter.
Yep.
Okay? So if I wait, and if I can really wait, depending on the weather in the fall, if I can wait until October even, and maybe if the weather really cooperates, the 1st of November, if I pick those apples in, they're going to be much bigger, much sweeter, and better quality apple in terms of the taste.
Yep.
So it's weather dependent. So around that time, that's when we do bringing in the harvest here off the farms in general, depending, of course, what you're growing.
Right.
And it's the harvest moon. It provides that light all night long as a full moon.
Mm-hmm. And what's the next full moon after the harvest moon called?
The hunter's moon.
The hunter's moon, also sometimes called the blood moon, though I prefer using that term during a lunar eclipse. Why?
For the lunar eclipse one?
Yeah, why would I call that a blood moon?
Yes, because the light is essentially almost completely blocked arriving to the moon, but some of the light skirts the atmosphere of the Earth, gets refracted or bent, and reaches the moon and get reflected back to the Earth, and it's mostly the longer wavelengths, so you get this reddish appearance depending on the exact composition of the atmosphere at the time, how much smoke is in the air, volcanic dust, all these sort of things. So the moon can look grayish to reddish to orange in appearance during a total lunar eclipse.
Yep. And so that's why I like reserving that term, is because the moon will turn often a nice reddish color during a full lunar eclipse.
Well, what about the hunter's moon? Why do you use that term then for November?
Because I actually looked that up as well. And it's because the deer have been spending all summer getting nice and fat and juicy. And the Native Americans, actually the term comes from them. And they liked hunting during the nice, bright lit night, because they could easily find the game and it was nice and fatted from the summer grazing.
Yeah, that's hunting seasons. And
So
a
it's
lot
hunting
of
season.
Locations is in that time frame in the fall, late fall, like that.
So that's why it's called the Hunter's Moon. And again, thank the Native Americans for that, because, you know, it wasn't referred to as that in Europe until after contact.
Right.
So, all right. Well, that's all I've got. So I'm going to look at Dean now because, because I think you've got some stuff you wanted to show us, especially about the fall sky.
Yes, Dean, you can't
Yeah.
stay quiet anymore. You have to say something.
All right, so I'll share my screen here.
Okay. And forgive me,
And-
folks, I'll have to be doing some resizing and changing things around.
We'll make sure everything. So we're trying something new here. So, so I figured I talk about a few things that we can see in the sky, and one thing that's been in the news a little bit is a comet. So, and the comet here is this 2023 P1 Nishimura. Hopefully, I'm saying that right. And so this was discovered by an amateur, and amateurs don't discover a lot of comets anymore because we have these automated robotic telescopes capturing them. So this was an amateur who just took a picture of the sky with a normal digital camera and a telephoto lens and captured this comet. And I believe this is the third comet that he's discovered. So
Nice.
this made a little bit of news then because this might actually be visible to the naked eye. The bad news, it's not as easy as you might think. And so, does it look like everything's working here?
Everything looks like it's working.
Okay. I do see it on the YouTube, so that looks like it's good. So I actually already have it selected. You don't see it anywhere. So I put it for tonight. We can see the time up here. Oh. So, and instead of static images, I'm going to use the software. This is Stellarium software that I use. This is free. I recommend it if you want to try and find things in the night sky. So I put it for tonight at 10 p.m. We don't see the comet anywhere. So let's go to the search here, and I'll click that. Well, that's no good. So let's go. We have to go a little bit later. It hasn't risen yet. Keep going later.
So the comet was below the horizon when you first started
Right.
searching.
The comet was below the horizon, so you couldn't see in the evening. In fact, notice now I'm at 4 a.m. and you can finally see it, but it's very low on the horizon.
So you won't see
rises,
it.
Right. It rises about 4 a.m. So really got to get to about 5 a.m. and then 6. Oh, we got twilight. So 5, maybe 5:30. So this is not an easy object. You're gonna have to go out at like 5:30 in the morning. Right now it's in the constellation Cancer. So it was in Gemini not too long ago. And if you saw my winter constellation tour in another podcast, these are winter constellations, Orion and Gemini. Cancer's kind of a spring. So these are now in the morning sky. So now it will be getting brighter, but the bad news is, I go day by day. Oh, it's going the wrong way.
It's going lower. Yeah.
Yeah. So it's going to be getting brighter as the days go by, but it's going to get harder to see, and you can't really wait, if you twilight's going to come if you wait for it to get higher. So there's this little window around 5 to 5:30, but it is getting pretty low. For those who know, altitude, the next, I think the 8th is going to be a Friday, and we are looking at an altitude of about 7 degrees. That's tough. You need a clear horizon. By then it's going to be in Leo. It's moving pretty quick, right? Just during that time, a little over a week, it went from Cancer down to Leo, so it's moving pretty fast.
I'm going to interject simply because I know that some of our viewers are a little further south than we are here. It's going to be even harder for you guys.
Oh yeah, so we can check that out.
Yeah.
So let's just go down to Texas. Oh.
And it's right on the horizon.
Got even lower. So, you know, I don't know, people in Alaska. Uh, well, now we're running into that they got twilight.
All the dang
So,
time. Yeah.
so
So just to be clear for people, so we have two competing motions that's happening at the same time. We have the Earth, it's in orbit around the sun, but the comet itself is in orbit around the sun also.
Right.
So relative to us, then the comet is inbound, isn't that correct? That it's heading closer and closer to the
right,
sun?
it's coming in toward the sun, and I believe it's around the 18th is perihelion, so that's when it gets to the closest.
18th of September?
Right.
Okay.
So we're getting pretty close, but near the sun, I mean, that means
In the
in
daytime
the
sky.
twilight.
Yeah, so
Right,
just,
so
just as a point of
Yeah.
warning, don't ever try to look towards the sun with a telescope or binoculars to try to see if you can find something, whether it's a comet like this or the planet Venus or whatever. The chance you're taking is extreme that you may accidentally cover the sun and have that light enter your eyes where you can do some permanent damage. So don't
Yep.
even take a chance of doing this.
I
When
will
you're really
second
near
that.
the sun.
And
watch
it,
it.
and if
Yeah.
you have a telescope that's designed to look at the sun, you're not
You'll be
going
able
to
to
see
see.
the comet.
yeah,
That's right. Yeah.
right. Yeah, so by the middle of September, we see this thing is too close to the sun. It's in the daytime sky. So, yeah. So your chance basically is over the next week, and having a good view low on the horizon in the east northeast. People are seeing it in binoculars, so but it's going to be a challenge to see this naked eye.
Now, the
So-
other thing is because it's inbound to the sun, it'll go around the sun and then come out the other side. So won't we see this comet in the evening sky? And it's just a matter of how bright it will be at that point?
Yeah, so I was looking at that, and it's if I go say forward to the 20th, and let's go to say 9:30 or so. Let's see if I can find it. It's actually not. It's kind of pretty low here. It's kind of near the sun, and as I get further away, there doesn't seem to be a good kind of the highest is around. So I guess actually before perihelion we do get an evening, but it's in the twilight still. So
Right.
yeah, as I get past that,
It's just heading
Yeah.
outbound at that point.
yeah, it
So-
doesn't. It looks like it's going more. Yeah, it's doesn't look like we're gonna get a good view after perihelion.
Yeah.
So from our point of view, it looks like it's staying fairly close to the sun on its outbound trajectory.
Yeah.
Okay.
So yeah, so it does not look like we're gonna catch it afterwards. So
That's unfortunate.
You know, that's one of the statements that some people make is that, you know, what will kill us is a comet that comes inbound, like near the sun, like in sort of the line of sight. And so we'll never know that it's on its way until it's too late. Well, there's not much you can do, even if you knew it was coming.
Right. Well, I always point out to people this one about comets. We don't really start seeing them until they hit about Jupiter and start outgassing,
Right.
warm up enough that they start outgassing.
Mhm.
So by the time they're at Jupiter's orbit, because they're screaming in from the outer fringes of the solar system, by the time they hit Jupiter's orbit, they're moving so fast. We've got a month, 2 months before they would be here anyway.
That's why there was plans for, I think ESA was involved in this, the European Space Agency. They were going to build a couple spacecraft, 2 of them in particular, and have them in orbit around the sun so they would react any moment's notice and try to intercept something that was inbound, that was discovered to give us a few months lead time, but not much more than that, so they could react. They're already out there, ready to go, have them
Right.
on the opposite side of the sun in orbit, for example. So there has been talk to try to mitigate this type of potential issue, because if a comet's coming in, I mean, that can do, depending on the size of it, you're talking about major damage if it hits
Yep.
the Earth. Even a global extinction type of event is possible.
Yep.
So we better have a contingency plan, if you like. And we have the technology, so it's not like
Yep.
we can't do anything. We're not like the dinosaurs, and the old joke is, you know, if the dinosaurs had a space program, they'd still be here. Well, we do have a space program, so we better be ready to react just in case.
Asteroids are nature's way of saying, how's that space program coming?
Exactly. Okay, Dean, so you want to keep going here on your
Yeah.
discussion?
So that's the comment. So that's been in a little bit of news. But yeah, this isn't something that you're just gonna walk out at 10 p.m. and look up in your backyard and say, "Wow, that's amazing." This is gonna be kind of 5 to 5:30 a.m. at least for Grand Forks Central Time. Um, and you can check in Stellarium. You'll have to update the orbital elements, but then you can check to see where it is for your location and time.
Yep.
So, because it might be a little different if you're not, around North Dakota.
And for updating
So,
the elements, I'll chime in that there's a great place to go for all the ephemerides, as they're called the Minor Planet Center.
yep.
And just do a Google search for Minor Planet Center, and you'll go right to it, and you can do a search for all kinds of comets, asteroids, and things like that.
Now this will download directly from there, but it's a bit of a challenge. And I can kind of show how you would do it, and then you go back and pause, and because you're not going to remember. There's a lot of steps. It's more difficult than it should be. But there's this configuration window I clicked, and then you go to plugins, and then Solar System Editor. I already got it selected because I did it just before the podcast. Configure, import, and then I chose the comet here and chose add objects. And so it's a little bit of trouble to get there, but once you do, the comet's in there, and then you can search for it. Go to the search and just type NISH, and that'll it'll autofill. So that's basically what I did, and then you can choose that. So
Cool.
And Stellarium is available for free, as you mentioned, both on the Windows, the Mac,
Windows,
the,
Mac, and Linux.
Yeah.
Yeah.
Oh wow!
these
So the three major platforms. Excellent.
Yeah. So there is a web version, and the web version might have the comet, just automatic. It might be all updated.
Right.
So I'm using the local software, but there is a web version you can run in your web browser as well.
Okay.
So
Is there a phone version of the app?
there is. They're
Okay.
in the app stores on some now. It changes. They used to charge a few bucks. So
Okay.
but yeah, they are in, I think, both the Google Play and the iOS App Store does have Stellarium in there. So
Excellent.
yeah, so it basically runs on everything, but you might have to pay a few bucks on the phone. I haven't checked lately.
Yeah, I was going to say the best part of it all, especially when you're running it on your desktop, is that it's free because I'm cheap.
Right.
Yeah. Yeah, so it is free, and it's nice software. So so
You know what the bird said when the cage fell apart? Cheap, cheap, cheap.
So
I think that's
let's
what
go.
a bird says all the time, though. Go ahead. Sorry, Dean.
Oh yeah. So I figure I'll go into the evening here, and we'll kind of take a look at what we can see. It's a little bit easier. Now we're in as we get into September. So I'm gonna zoom out a bit. And you can see using it's pretty easy. I basically just use my mouse and I drag the sky around.
Good way to know where the constellations are relative to each other. Just play around.
Yes. So yeah, and down in the corner here, you can click, the constellations. So by default, it just is the sky. And so if you don't know what anything is, you can click the little buttons here, and it'll help you find the constellations. It'll even name them. So one of the things you can look for as we get into September is constellation Pegasus. So Pegasus in the sky is going to be this big square. I can probably get rid of the time up here. And I'll turn the lines off. See if you can still see the square, because it turns out the actual night sky does not have the lines there for you. So
it's very inconsiderate that way.
So it would be a lot easier to find things if the lines were there.
Yep.
So you will have to find the pattern without it. So, but there is this nice square. Now it might look right like it is here. It looks like a diamond when it's in the east. It'll look more like a square when it's in the south. And there's an interesting thing you can find, a few interesting things. Now, the main thing you want to look for as we get into the fall is the Andromeda Galaxy. The Andromeda Galaxy is the closest galaxy to our galaxy, the Milky Way. It's about 2.5 million light years away. As far as galaxies go, that's next door. Like,
Closest one that's similar to our galaxy.
Yeah, closest large spiral.
yeah, it's the
Okay.
it's the closest large spiral.
Because we
There
do
are
have,
some
yes, you were going to say,
dwarf,
sorry.
yeah. So we do have dwarf galaxies like the Magellanic Clouds that orbit the Milky Way.
We have a
So-
few small spirals that are closer.
Now,
too.
Robert, here's
Yeah.
a question for Robert, see if he knows.
Uh-oh.
Dean, I know you know, so don't answer it.
Oh lordy.
Uh-oh.
Robert,
Uh-huh.
how many official constellations are there? Being you're on a timer. 1, 2,
150?
3. No, less than that.
Okay, 85?
Oh, you're so close. 88.
Oh, that's close.
88, okay.
And that is dictated by the United Nations of Astronomers. Do you know what the United Nations is of astronomy?
IAU?
The IAU, the International Astronomical
Union.
Union.
Yep.
So they denoted officially 88 constellations.
Yeah.
So
I know most people pop off 12, and it's like, no, there's just 12 that are somewhat important because they happen to follow along the path of the sun.
the zodiac.
The zodiac.
Yeah,
And 13 if you want to count.
13 if
Ophiuchus.
technically,
Yeah.
yeah.
exactly.
He goes through a little corner of that,
Hmm.
but that doesn't show up on your horoscope.
No.
No.
So,
For those of you who even look,
Now, I do want to mention about the Great Square and Pegasus, which the Great Square is an asterism. This is actually very easy to spot, folks. It takes up a nice chunk of the sky, so it's Big Dipper sized.
yeah, I think it's easier to see in the sky maybe than recognizing it on the
Yes.
screen here.
yeah, even in
So-
light polluted skies.
It's huge.
Semi-light polluted.
3 of the
Yeah.
4 stars are visible and usually in light polluted skies. The 4th one is a little dim.
Yeah, if you're going to stand in, I don't know, Times Square in New York City and
You
look
won't
up,
see any of them.
you can see the moon.
Right.
Yeah, that's a moon and Venus, and so
And the sun.
Um,
That's the only star you probably see, right? Yeah.
So anyway, you were talking about the Andromeda Galaxy. So
yeah. Well, and now that you're talking about planets, I should if you're watching this in 2023 and not some other year, Saturn is out now. So we kind of had a planetless summer as far as the bright naked eye planets. But now we do have Saturn out, and this is actually a good time. If you had a small telescope, this is the time to go out and take a look at Saturn.
I'm glad.
So it's going to be good for the next month. So you don't have to go out right away, but we're right now in a good time for Saturn.
Yeah, and I'm glad you mentioned, a small telescope because you can actually see the rings of Saturn with a good pair of binoculars. So, you can go out
very
and
good pair. I
see
don't-
these things,
Very, very good.
Yeah,
Which
well,
means really expensive pair.
it does. I'm
Yeah.
I figure you probably need about an 80 millimeter objective.
So you would need pretty high power.
Yeah,
But I mean, they do make things like 20 by 80s and that kind of thing. So
right.
Yeah.
So
Yeah, you're not
your normal, 10 by 50s probably.
Probably
you
not.
You can see the moons of Jupiter in those.
Yeah.
right.
But rings of Saturn, you want to get up to usually in a telescope, for a telescope low power would be 50 power, and you can see the rings at 50
Yeah.
power.
I know I saw them very clearly through a 4-inch objective, so I know 120
yeah.
millimeter or 4-inch telescope will do
Yeah.
excellent.
Oh yeah.
So
Yeah, you don't need a lot of aperture.
right.
So
And if you
it's,
wait,
you just need to zoom in enough.
now if you wake up very early, or if you stay up really late, like me, stay up really late, if you look towards the east, you'll see a really bright star-like object in the sky at around 2 a.m. or so. Do you want to tell people what that is?
My guess is that you were seeing
The other planet.
Venus.
Yeah. No, Jupiter is what I'm getting
Oh,
at.
Oh,
okay.
yeah, Jupiter's
Oh,
there.
okay.
Yeah.
Yep, there's Jupiter. Yeah. Yeah, so Jupiter, well actually it was up at 10 at 11:30 here, so just barely.
Yeah.
So it does rise up, but right now Jupiter's mostly a morning object. So after midnight you can see it pretty much all night long. So you don't have to get up early, you can stay up late. So it's up for most of the time after after midnight here.
Yep.
Yeah,
And
so it's just
so
that it's so much brighter compared to Saturn that it dominates the sky in the east.
Yeah.
late
yeah,
afternoon.
people notice Jupiter. People don't always notice Saturn
Mhm.
naked
Right.
eye.
Mhm.
So
And I mean, it's the Venus and the Moon are the only objects that are going to be brighter than Jupiter, if I'm not mistaken. Right?
yeah, I think yeah.
Yeah,
None of the other planets get as bright as Jupiter.
Right. And none of the stars for sure, other than maybe Sirius, but I'm not even sure it gets that bright.
Yeah, not when Jupiter's at its brightest.
Right.
So I think Sirius, the magnitude's like minus 1.4, and this actually tells us Jupiter is minus 2.5 right now. So
yeah,
so quite a bit brighter
quite a bit.
than
Yeah.
Venus. So or
Sirius.
Sirius, there we go. Yeah, Venus will get to -4. So
Right.
yeah.
And the reason I'm bringing up Sirius is because that's the brightest star, not Polaris. Sirius is the brightest star in the northern hemisphere.
Other than our sun.
Other than our
Click
sun.
on Saturn. What do you have for a magnitude of that? And then you can do the comparison and brightness.
0.45. So
Oh, wow.
0.45. So that's about 3 magnitudes difference in brightness.
Yeah.
yeah.
So each magnitude is about 2.5 times. So take 2.5 times 2.5 times 2.5, and that's the difference in brightness
Right.
between the two.
So about 12, somewhere in there.
Yeah. So Jupiter is a lot brighter than Saturn right now.
Yeah.
15.
It's like about 15 times. Yeah.
So, yeah,
So,
there you go.
so
Yeah. So these are things
Yeah.
you can see in the sky. And I noticed there's another bright star that's over there near Jupiter in the morning too. And that's Capella, which is a
Yep,
nice
and we
star
got
to look at.
we got the Pleiades star cluster
Okay.
near Jupiter right now.
And I will mention that the Pleiades is an object that a lot of people mistake for the Little Dipper because it's
Yeah.
tiny and dipper shaped. But
It's a
the
very
Little
little
Dipper is
dipper.
actually little only in comparison to the Big Dipper. So the Little Dipper is not that little, folks.
Well, in England, they call it the plow
Oh, okay.
because it looks like a little dipper, like a plow
Okay.
in the
Hmm.
field. So that's, they got Seven Sisters, the plow, these kind of descriptions that people have used.
Yeah.
Dean, you mentioned the Andromeda Galaxy.
Yeah, we haven't gotten to
We
that
haven't
yet.
gotten to that yet.
So you want to see the Andromeda Galaxy? You can see another galaxy now in a dark sky. You can see it naked eye.
Mm-hmm.
But most places you're going to need binoculars. But the good news, you can see it in binoculars in quite a few places. So you don't necessarily have to go out of town to see this. And so there are different ways of finding it. What I use the Pegasus, the Great Square of Pegasus here. And one thing I can do here is visualize. Pegasus is supposed to be this horse here. So I always think of it as the other way. So so this is supposed to be Pegasus, and I use it. There's like this little triangle. I think of this like an arrow, and it's pointing to this star right here. Now everyone has their different ways. So this is my way. So I start right, and anyone else who's found it, they're like, I don't find it that way. So, but this is how I find it. So I start here, and then I count 1, 2, and then I go up 1, 2. Now, if you go and you look at that star in a pair of binoculars, and that's kind of faint. You might, depending on your sky, a dark sky, you can see it, but you might not see it if you got some light pollution. But you zoom in a pair of binoculars. Now, there's this fuzzy thing. Hopefully this is showing up.
Yep.
That fuzzy thing, you'll see this in binoculars. This is the Andromeda Galaxy. It's very close to this star here. So you can find that star. You can see this, and this will show up in binoculars. A dark sky, you get out of town a ways, and you can see this visually with just your eye. So it's kind of a neat thing. In a telescope, you can see a couple dwarf galaxies around it. And so this is M32, and then up here is M110, and you can see both of these. Now M32 is in the telescope is the easier one. It might not be obvious in the software, but that's actually the easier one. It looks just like a fuzzy ball. This one here, M110, it's bigger but dimmer. So, and this is a pretty big object. In fact, this is a telescope field of view about like that.
Mm-hmm.
So
Yep.
this thing is probably bigger than what a telescope can show. In fact, usually you look at Andromeda and you'll see M32, that dwarf, but you have to move your telescope a little bit to see the other one, right? It's kind of off the side. And depending on your telescope might flip things around and rotate things. Oftentimes for me, this is rotated around. So M32 is above Andromeda and M110 is below Andromeda. So it might be rotated around. So but this is the easiest galaxy to see. So if you've never seen a galaxy, this is the time, September, October, that's the perfect time to go out and look for the Andromeda galaxy. If you want a challenge, there's another one nearby. Let's bring up the lines again as a reference. So this was Pegasus, the big square over here. This is actually Andromeda. You know, it doesn't look like much, but these lines here, that's the constellation Andromeda. We have Triangulum down here. Maybe I should put the names up. So Triangulum. If you take this distance from Andromeda down the galaxy, down to the star Muroc, or however it's pronounced, and you keep going that same distance, there's another fuzzy thing there. This one is a challenge. People in very dark skies say that they can see this. This is M33. This is another galaxy about the same distance, a little bit further, but not much. And so this is another galaxy in our local group. So our local group of galaxies, as the three big ones, the Milky Way, Andromeda, and this M33, sometimes called the Triangulum galaxy, just because it's in the constellation Triangulum. So, but this is a dimmer, more challenging object. But I have seen it in binoculars, but it's more of a challenge.
Right, so it's also a spiral galaxy like our own Milky Way and the Andromeda galaxy.
Yep.
Right. Yeah, all three of these are spiral galaxies. And this one is a little more noticeable that it's a spiral, where Andromeda is kind of tilted. We're seeing a little more edge on.
Right.
So it's not as obvious that it's a spiral.
And we do have a question from someone. JMPWRD asks, if you had to choose a favorite galaxy, what would it be?
Oh boy. I tend to like the Whirlpool galaxy. I don't know if I have a good reason. I think it's the most photogenic galaxy. So that's M51. It's fairly, if you have a telescope, it's right underneath the handle of the Dipper. So there's the Big Dipper. You find this last star, go down a little ways, and you zoom in with a telescope, and you've probably seen this one. It's a very popular astrophotography target. And this is always a fun one to look for. It's actually two interacting galaxies. And in a telescope, at least an 8-inch, I'm pretty sure in a 6-inch, you can see both parts of these. And you can even tell which one is which. But you do need a bigger telescope to see the spiral arms. Usually what I see is a big fuzzball and a smaller fuzzball. So, but as you get to a bigger telescope size, you can start to tell that the spiral, and I believe this is the first galaxy that spiral structure was seen in visually in a telescope.
Okay. I didn't know that. But
so, and you're thinking about like the guy in Ireland, was it Lord Rose or whatever it was? The guy with the huge telescope, remember?
Yeah, I don't know his name.
Yeah, I don't remember the guy.
Was it the third Earl of Parsons or something?
Something like that. Yeah.
Yeah. So Robert, what's your favorite galaxy?
I'm partial to M82, and I like calling it the Guppy Galaxy because it looks like a guppy, through a telescope. So I like M82.
Dean, can you bring up
that's
that?
a nice little pair.
Mm-hmm.
Yeah, we got so M81 and then M82 up above it, and that's in a wide field. This is about a telescope field of view here. Maybe I'll get this that out of the way. You can see both of these. So M81 is your standard spiral. These are fairly nearby. And then we got M82 here, and that's a weird, irregular galaxy.
And like I said, through the astro images that I've taken of it, it looks like a little guppy. You can see the guts and then the semi-transparent body of it. So I've always referred to it as that. But M82 is nice, and it's a fairly challenging target to get and get right.
Now, can you guess my favorite galaxy?
Probably Milky
The
Way.
Milky Way. Very nice. I'm a little biased, but it's the Milky Way.
Yeah.
Our own galaxy.
There you go.
It's also a good candy bar.
Mm-hmm. I'll agree there too. Lots of caramel.
Okay, Dean, it's all yours.
All right. Well, there's the Milky Way.
There we go.
So the best time to see Milky Way, we're getting a little toward the end of Milky Way season, but like July is a good time for the Milky Way. In fact, I moved the time to the end of July. So July and August, look to the south, look for Sagittarius, and you'll see the Milky Way going up. And then if you have depending on how dark the sky is, you can trace it further up overhead. But you need a pretty dark sky to even see it at all, even in the
Yes.
brightest part. And something like 80% of the population cannot see the Milky Way where they live. And I think
Sounds
we're
about right.
all in that group. I have to travel out of town to see the Milky Way.
Mm-hmm.
Unfortunately.
And we're in some place like North Dakota where there aren't a lot of major cities nearby. So, somebody that lives like where I grew up down in the deep south, you're going to have to go way away from things.
Well, you can look at satellite images taken of the United States during the nighttime, and you can see all of the lights, the city lights, and essentially east of the Mississippi is just swamp. There's like one big light that's turned on.
Yep.
And that's a lot of people that live along that area on the eastern seaboard.
Yep.
So, hundreds of millions of people, around the world, probably billions of people around the world have probably had very little contact with seeing the Milky Way, unfortunately.
They probably have little contact with seeing the stars,
Yeah.
much less the Milky Way.
I mean, you can do a survey of all the professional astronomers in the world and get an idea of where they grew up. And probably the vast majority, as far as I heard, grew up in rural areas where you
Right.
can actually see the stars in the Milky Way at night.
That's probably a good estimate, yeah.
Yeah.
But
So, Dean, do you have anything else you'd like to bring up about the sky for the fall?
Well, I can brag about a picture that I took a little earlier in the month.
Sure.
That
Okay.
might be a good way to end.
right.
So this is a picture of a bunch of galaxies. I actually took this during the Perseid meteor shower, and I probably missed a lot of meteors because I was messing around with my telescope and camera and everything. But so I went out to a dark sky. We actually went out to the north unit of Roosevelt National Park and watched the meteor shower from there.
And that's
And-
for people who are not familiar with that. Do you want to describe the location roughly?
Yeah, well, basically it's the western part of North Dakota.
Out in the
And,
Badlands.
Yeah, the North Dakota Badlands. And there's actually two parts. As a national park, there's a south unit and the north unit. And they're both pretty dark. A lot of light pollution maps show the north unit brighter than it really is because there's a lot of flaring of natural gas around there. You don't really notice that as far as the light pollution, though. The main light pollution here is from this town, Watford City, that's north of there, that became like an oil boom town and grew by a lot. And it used to be barely a small little town. You barely could tell it was there in the light pollution. It has grown, and we do see that glow in the north now from there. But this is actually a galaxy near Pegasus. I could actually show where it is. It's up right in here. Let's see how good I am. Can I actually zoom in on it? Oh, that's not it. Oh, I used to be able to find this, but oh, there we go. So this is NGC, so it's a catalog number 7331 is the big galaxy, and then over to the right is Stephan's Quintet, which is a little grouping of galaxies. And even NGC 7331, it has galaxies underneath it. Now, not all these galaxies are related to each other. So, in fact, I'll go back to my picture since I took it. So the NGC 7331 it's about 40 million light years away. These little ones underneath, they look like they might be little dwarfs that orbit it or something. No, they're all over 300 million light years away. So they're actually a lot further away. And so it's just visual grouping. They look close to each other, but the distances are huge. Now over on the right side, there's Stephan's quintet, and most of these galaxies are related to each other. They're about the same distance. They're about 200 million light years away. This one down here, that kind of bluish bigger one, that is closer. It's 40 million light years away. It's actually about the same distance as the big NGC 7331. So you wouldn't expect us looking at this as the big galaxy on the left and this galaxy over here, they're about the same distance. Everything else is a lot further. So these ones, and they're a little bit different color, a little yellower. Yeah, they're like 200 million light years. I'm rounding, but and then all these other ones are, they're further than 300 million. So,
Cool.
but it's a nice little grouping. The big one you can see in a reasonable telescope. I'm pretty sure I've seen it in an 8-inch telescope, but you want to start seeing these little ones and Stephan's quintet. I have seen them in an 18-inch telescope, but that gets to be a challenge. You need a bigger telescope for that. So,
And unfortunately, I'm going to have to call a halt because we are.
oh
at
yeah,
our
we
time.
are at an hour.
So,
Yeah.
so Robert, I gather from all this that space is big. Really
Space
big.
is really big, and a lot of things are really far away.
Well, in that big space, we have a lot of things. So if you're interested in studying more about astronomy, about astrophysics, physics in general, and science, come to the University of North Dakota. In fact, we have not only on-campus classes that you can attend or get involved in various programs, we also have a huge suite of online courses, which means you can take them from anywhere. In fact, you can do your online courses in your pajamas from your bedroom if you like. How's that for comfort?
Yeah, I like that.
Yeah, there you
Wish
go.
I could work like that, but oh well.
Yeah. So yes, if you're interested in science, please do not hesitate to see what we have to offer, and I think you'll be pleasantly surprised. So with that, we thank Dean for participating in today's experiment. We'll see how it goes and whether or not we have the brave enough to invite somebody else here at some later time to do
Right.
a podcast or two. And we always leave you with a quote. So today I'm going to leave you with a quote from Stephen Hawking. Most people have heard of Stephen Hawking. I probably don't need to say much about it. And here's his quote, well fitting for today's subject. The quote is, "Look up at the stars and not down at your feet. Try to make sense of what you see and wonder about what makes the universe exist. Be curious." Thank you very much for watching.
Thank you, folks.
Don't forget to give us a thumbs up and subscribe if you like this podcast. The next podcast will take place next Tuesday, September the 4th at 3 p.m. Central Daylight Time.
We'll see you then. Have a good day, folks.